Fitter. Basic fitting tool. Outside and inside micrometer. A micrometer is a precision instrument used to measure dimensions such as length, diameter, and thickness, generally within an accuracy of 0.01 millimeters. The measurements by micrometers can be more accurate than those given by other measuring devices, such as vernier calipers, but depend very much on the user's care. Micrometers have two scales, a primary scale on the barrel or sleeve and a secondary scale on the thimble. Values are taken from each of these scales and combined to make the total measurement. A micrometer is classified into two types, that is, outside micrometer and inside micrometer. Outside micrometer. Micrometers used to take the outside measurements and measure thickness are outside micrometers. Inside micrometer. Micrometers used to take the inside measurements are known as inside micrometers. This micrometer has no U-shaped frame and spindle. Instead, the measuring tips consist of jaws with contact surfaces hardened and ground to a radius. Now let's discuss the range of micrometers, which is essential for further understanding of micrometers. The range of any micrometer can be defined as the minimum value that the instrument can measure. Outside and inside micrometers are available in millimeter and inches. Outside micrometers are available in 0 to 25 millimeters, 25 to 50 millimeters, 50 to 75 millimeters, 75 to 100 millimeters, 100 to 125 millimeters, and 125 to 150 millimeters. The range is also measured in inches, such as 0 inch to 1 inch, 1 inch to 2 inches, 2 inches to 3 inches, 3 inches to 4 inches. For all micrometer ranges, the graduations marked on the barrel are only 0 to 25 millimeters. Inside micrometer. The range of the inside micrometer is based on the jaw and extension rod. The size of extension rod is 25, 50, 100, 200, 400 millimeters. For all micrometers, extension rod for 50 to 200 millimeters. To dismantle and carry out cleaning or adjusting a micrometer, it is essential to know the functions of its various components. The parts of an outside micrometer are frame. The frame is made of drop forged steel or malleable cast iron. All other parts of the micrometer are attached to the frame. The frame can be semicircular, semi-rectangular, or in U shape. Range and least count are written on the frame. This frame is heavy and thick, making it difficult to strain under mechanical and thermal stresses. Anvil. The anvil is one of the measuring faces fitted on one corner of the micrometer frame. It is made of alloy steel and finished to a perfectly flat surface. Anvil is a fixed part of a micrometer. Job or workpiece is kept between anvil and spindle. The diameter of the anvil should be equal to the diameter of the spindle within 0.04 millimeter axis of both and in exact alignment. Spindle. It is a movable part of the micrometer. One end of the spindle is the measuring face, whereas the other end is threaded and passes through a nut. The threaded mechanism allows for the forward and backward movement of the spindle as per the requirement of the workpiece. The spindle passes through a split internal thread, forming the barrel. The outer portion of the split internal thread has tapered external threads. A threaded taper nut is fitted on this. Spindle lock nut. The spindle lock nut is used to lock the spindle at the desired position. However, the spindle cannot move after locking with the help of a lock nut. Therefore, a diamond knurled spindle lock nut is generally desirable to be provided with a micrometer. Barrel or sleeve. The barrel or sleeve is fixed to the frame. The datum line and graduations or main scales are marked on the barrel. Thimble. The thimble has a hollow taper to match the tapered nose fitted on the spindle. The circular scale is marked on the thimble. The spindle is attached to this, a kind of scale. It moves on the main scale by rotating the thimble, changing the primary scale reading. Ratchet stop. The ratchet stop ensures a uniform pressure between the measuring surfaces of the micrometer while measuring. The ratchet stop will slip beyond a certain pressure, thus preventing further advancement of the spindle when excessive force is used. This is mounted on the thimble of the micrometer and it connects with the spindle when assembled. A special spanner uses to disassemble ratchet stop. Inside micrometer. Many parts such as frame, anvil, thimble, sleeve, screw nut, spindle lock nut and ratchet stop are common outside micrometer except extension rod and spacing collar. Extension rod. This is fitted in the hole provided in the barrel of the micrometer head. It gives another measuring surface. It is available in different sizes. Spacing collar. It is added to the extension rod for additional length. It is also available in different sizes. Working principle. The micrometer works on the principle of screw and nut. The amount of axial movement of a screw made accurately can be measured by its rotational motion. This is because the pitch of the screw is constant. The measurement made due to the rotational movement is some amplified form of the actual axial direction of the screw. Outside micrometer. The longitudinal movement of the spindle during one rotation is equal to the pitch of the screw. Therefore, the spindle's movement to the pitch's distance or its fractions can be accurately measured on the barrel and thimble. Inside micrometer. The inside micrometer works on the same principle as the outside micrometer, except the barrel reading on some caliper is reversed. The inside micrometer is designed for measuring holes, slots and grooves from 5 to 50 mm in size. One of the jaws is held stationary at the end, and the second one moves by the movement of a thimble. This facilitates the inspection of small internal dimensions. In this video, we have learned about outside and inside micrometers. Thank you.